Welcome to the Explainer. Today, we're going to break down one of the most fundamental concepts in all of programming, arrays in Python.
Okay, let's dive right in. A staggering 90% of questions in data structures and algorithms involve arrays. I mean, that's huge. Things you hear about all the time, like two-pointer techniques or sliding windows, they're all built on top of arrays. They really are the true backbone of code.
So, let's imagine a scenario. How would you handle a huge amount of related data, like, say, 1,000 student roll numbers, without completely losing your mind? You've got to have an efficient way to manage all that information, right? Well, the answer is definitely not creating 1,000 different variables. Can you imagine? That would be an absolute nightmare to keep track of. Instead, you use a single organized structure. And that's where the power of arrays comes in to save the day. So here's our game plan. We'll start with why arrays are so critical. Then we'll see what makes Python's approach so different, its own unique twist. After that, we'll explore the two main ways to create them, the simple built-in module and then the powerhouse library, NumPy. And finally, we'll get our hands dirty with the essential operations you'll use every day. Now, what's really interesting here is that if you're coming from a language like C++ or Java, you probably think you know what an array is. But Python? Well, Python kind of plays by its own set of rules, and that gives you an incredible amount of flexibility. At its core, an array is really just a super organized collection of items. They're all stored one right after another in memory. The key thing is that you can grab any item you want instantly just by using its numerical address, its index. And remember, in Python, like most languages, we always start counting from 0. And this slide really nails the key difference. In languages like C++, arrays are very rigid. You set their size, and that's it. And every single item has to be the same type. But in Python, what we usually call an array is technically a list, and it's completely dynamic. They can grow, they can shrink, and you can even mix different data types, integers, strings, you name it, all in the same collection. So you might be wondering, if Python's regular lists are so flexible and amazing, why would you ever need a more traditional, rigid array? Well, it all comes down to one thing: memory efficiency. And the first way to do that is with the built-in array module. It's a pretty simple three-step process. First, you've got to import the functionality. Second, you tell it what kind of data you're storing using a special little type code. We'll look at that in just a second. And third, you just give it your data. Simple as that. Okay, so those type codes you see here, they're just shortcuts. For example, I creates an array of integers. But if you were working with high-precision decimals, you'd use D for double. This is all about being super efficient with memory when you know for sure that all your data is going to be the same type. And while the array module is fine, it works, it's built right into Python, it's not really what you'll see people using for professional data science or really complex analysis. It's just a little bit limited. Because for real power, for real flexibility, the entire industry turns to a library called NumPy. It is the undisputed champion when it comes to numbers in Python. So let's get to the industry standard, shall we? NumPy arrays. This is where things get really, really powerful, especially if you're working with data. So why is NumPy the king? Well, it's better in almost every way for data work. The syntax is way cleaner. You don't have to mess with those clunky type codes. It has a ton of functions for creating arrays right from scratch. And this is the big one. It handles multidimensional data beautifully. We're talking grids, cubes, you name it. It also has these amazing shortcut functions. I mean, check this out. Need an array of 10 zeros? Just type zeros, 10. Boom. An array of 10 fives? Full 10 5. It saves so much time and makes your code way easier to read. Okay, so we know how to create arrays. Now let's get to the fun part. How do we actually work with them? Adding things, removing them, selecting just the bits we want. This is where you really start to code efficiently. You've got really precise control over your data. You can use append to just tack an item onto the end. If you need to put it in a specific spot, you use insert. To get rid of things, pop removes an item from a specific position, while remove actually hunts for a value and deletes the first one it finds. And what if you just want to change a value that's already there? Oh, it's incredibly easy. You just access it by its index, in this case the third element at index 2, and assign a new value. Done. But maybe the most powerful and I'd say most Pythonic way to select data is something called slicing, and it's exactly what it sounds like. It lets you grab a specific piece of the array, a subsection of your data, just like taking a slice of pizza. This syntax right here, myArray 2 to 5, is the key. It grabs all the elements starting at index 2 and goes up to but not including index 5. That last part is a classic Python rule you have to burn into your brain. The start is inclusive, but the end is exclusive. And it gets even cooler. You can use negative numbers to count from the end of the array. So -1 isn't an error, it's just the very last element. -2 is the second to last, and so on. This gives you amazing flexibility for grabbing data. And here it is, the coolest trick of all. You will use this constantly once you learn it. This simple slice notation, the double colon with a -1, it instantly reverses the entire array. No complex loops, no functions, just one clean, beautiful line of code. So let's bring it all home. What's the bottom line? First, arrays are the absolute foundation. Second, Python's built-in lists give you amazing flexibility for everyday tasks, but when you need real performance and power, the array module and especially NumPy are what you need. And mastering these core operations, particularly slicing, is the key to writing clean, fast, and professional code. You know, we've mostly focused on one-dimensional arrays today, just a simple line of data. But as the slide asks, if a 2D array is like a grid, maybe a spreadsheet or a picture, what could a 3D array represent? Think about it. Maybe a cube of scientific data or a video, which is really just a stack of images. That's the power of NumPy, and that's a topic for another day. Pretty cool to think about, right?